So the space science and technology is also another domain, but space science is nothing to do with the any specific technology. It is a technology which can catalyze, which can rather accelerate the conventional technologies, that I should say. Anybody space science, if you ask, people will remember satellite and rocket. Obviously, there are the two elements which creates a lot of wealth to the nation to do so many activities. In addition to that one, why the technology, space technology is required for advanced nations, what is happening, what has happened in the past, how actually the evolution of the humanity has happened, how the celestial systems have been formed, what is the genesis. It is a continuous endeavor. Of course, our Hubble telescope has given lots of information, and everything has been documented, well documented in the respective websites. But James telescope is further enhancing the fineness of these explorations, not only black holes, not only some kind of multiverses, not only and how the stars are formed, how how different celestial bodies behave in the universe. Something like that. Very interesting facts have been now getting out because of the research, and huge research is going on. I request all the teachers to explore these websites where lots of information is available in terms of videos, in terms of images, as well as in terms of documentaries and explanations. So Big Bang Theory, somebody is questioning the Big Bang Theory much before that one, something has happened. So incidentally, all these things were talked in our ancient books like Vedas. That is where now government is emphasizing that the ancient culture of the country has to be brought to the notice of the students, where we started. When we have started such kind of evolutions, Aryabhatta, Brahmihira, such kind of people who, without any calculators, without any supercomputers, they were estimating the Kalamana, they were estimating the seasons, they were estimating what is the celestial bodies. And in terms of Puranas, they say that, okay, we have gone from one loka to another loka. These maybe many people may think that these are all fascinating stories and myths. Maybe one point of time that is becoming, that may become true. So our ancient people are much sophisticated scientists than us, who could travel across the universe and within seconds. Now we are looking for nuclear propulsion to reach out to the Mars as much as possible. Otherwise, it takes months of time. Probably our ancients have excelled all these technologies, vanishing of mass from here and reappearing at somewhere. So Manovegam, it is called as, Manas is the fastest moving what you call philosophy on the existence, Manovegam. So that is the speed now people are working. That is the science, the exploration and the research is happening elsewhere, including in India, to explore the celestial objects. Okay, these are all some of the fundamentals I am just going through. Many people, you are aware how actually when you start explaining how the universe is formed, what it contains. But when you talk about what is the dark energy, please talk about what the energy all about. What is the formation of energy? How the energy can transform. The matter is only 5%, rather 25% dark matter, which is not visible. What is there? Nobody knows. So this is called Shakti, energy, and this is only the cause for entire formation. An energy is taking a shape into matter. The matters are again getting perished, joining the Panchabhutas, whatever the philosophies what we have, and ultimately it is getting absorbed into different what you call philosophies like earth, water, fire, and akasha. Again, they are taking rebirth. This is the beautiful mechanism. If something, because we don't have justification today to explain this Vedic philosophy. Otherwise, if one point of time, how actually energy can be converted into matter and matter can be converted into energy, if that happens, it is what the appearing, vanishing here and reappearing somewhere. If you want to go to America, just you think that I'm there in Los Angeles or California. You just disappear here and you will become a photon. Through some means, you will get transferred over there within 1 second and reappear over there. Such kind of research somewhere is going on to understand. Now energy can be taken transformation to another energy, but energy to matter, matter to energy is the one research that is happening on many universities. How the galaxies are formed, what the nebula, these are all the things what I was telling. These are all the places for exploration and understanding how actually the celestial objects are formed or behaving, where are they, what are the advantages, what are the threats, what are the weaknesses, how actually these can be explored, why we should explore, why, what is the reason of exploration. If at all you find greatest minerals over there which will satisfy the human mankind for many of the applications, how to explore them. Would the rockets are enough, or you have to take a spaceship and mine it and bring it back to Earth, or you can make your own colonies over there, make final products. That's what one in space manufacturing is the subject that talks about how actually in the space the manufacturing and fabrication, other things can take place. 3D printing, some kind of polymers, and some kind of new manufacturing technologies are being evolved to convert these precision and very valuable materials which are available in the on the moon and asteroids to get converted. Now research has started. I'm not telling that. We have already reached a reasonable and worthwhile milestone to explain the applications. But asteroid mining, we call it as. Moon mining, we call it as. What is the energy that are all available in the cosmos? How actually we can bring them for the benefit of the mankind. There are so many dangers. Let's say solar flares are there, solar coronal mass emissions are there. How actually they will cause harm to the humankind? How actually we will protect from these kinds? How the magnetosphere around the Earth will protect us? So these are all the fundamentals have to be told to the students so that their understanding on the fundamentals about the galaxy. And incidentally, these are all the technologies which can be made applicable for some reason or other in the innovation process. When a magnetosphere rejects the coronal mass emissions, which are very high power photons, if you can bring that same technology to a place where such kind of radiations are happening on the Earth at different locations, probably the humankind over there will get relieved from the numerous diseases out of radiation. Radiation environments are there. How to create an environment or a safe suit or a enclosure, how to which will protect the people, the living beings over there from the unusual and unwarranted radiations and other elements. Even fire creates some radiation. Okay, such kind of technologies, if you inspire the students, that will give a leverage for them to innovate, to think, to do some research for the common benefit of the people. These are all solar system, and I'm not going to talk much about these historical aspects. Then talking about, when you are talking about the fundamental principles, whether it is a Kepler's laws or Newton's laws or any laws, how actually these technologies will be adopted for the applications. This is one area teachers have to keep in their mind when they are talking about the technology or the principles. They should not simply read the principle and get it by heart to get the marks. But the teacher should know where these technologies are applicable for the general applications. If without these things, what will happen? What is zero G? Why that zero G concept has come? Zero G means it's not zero gravity. It is something like that continuous free fall condition where you feel that you are experiencing zero gravity condition, and you just float in the space. So that is condition. How it creates, what kind of amusements are there for doing so, and how actually what are the biological let's say actions that they take place during this zero G condition. How to live, because tomorrow, after maybe 300 to 400 years, if this education is not passed on to the next level of people, probably Earth may get exhausted. We may have to find colonies elsewhere. So for them, what kind of medical technologies are required? What kind of protection living systems that are required? These are all the new things we have to inspire the students, to drive them for innovation, to drive them to think. Even let's say if you train 1 lakh people, even 100 people, if they start thinking in this line and start venturing into new technologies and ideation process, that itself is more than enough for our endeavor, what we have been doing. Then the satellite, what the one very usual question and every space scientist face is, how actually when NASA, ESA, or China or Russia, when they reach the moon within let's say reasonable time of 4 to 5 days, why India has taken 45 days? This is a very WhatsApp question or Google question. Okay, so here the question is, with the less cost, how we have applied the fundamental principles to still achieve the greatest achievement. These are all the fundamentals of Kepler laws, the fundamentals of how a satellite rotates around an object, two objects. A satellite rotates about the parent system in an elliptical plane. That elliptical plane, how actually that will be maneuvered, which is the place where if you give a infinitely small effort or thrust, which will create a big maneuver in terms of apogee, perigee. So these are all the subjects which you have to tell to the students so that they will get convinced for many of their questions. So this is one thing what we usually tell when a perigee, apogee is the largest point and perigee is the smallest point to the earth. Always it will not, any satellite, when you just push it with escape velocity, when you leave with some escape velocity, that will be moving around the earth, let us say satellite, I call it as. When it is moving, it is not the circular path, it is an elliptic path, because based on the Kepler's law. So when it comes to perigee, if we just fire a small amount, a 100 kilometers raise in perigee may cause thousands of kilometers raise in apogee. So that is why with a small effort, you will expand like a string. Ultimately, the perigee you will raise to such an occasion, such a level where it just near to the moon in case of moon maneuvers. When it goes to the highest point or farthest point, you just make a small maneuver there. You jump into the other orbit, let us say the domain. So this is how we manage with the fundamental principles without spending huge amount on the rockets. That is how ISRO has always been praised for very low cost missions to achieve greatest things. That is the thing that you have witnessed in the recent past, Chandrayaan 3, with almost, I think, 1/5 of the cost or even low compared to the advanced space nations. We could achieve what advanced space nations never achieved so far. So these are all the fundamental things you have to tell to the students for them to achieve. See, many people read, because even the Kepler class, I do not know nowadays, whereas when we were studying, these principles were in the higher classes. How actually these coverage will be there as per the Kepler laws. It is a very simple thing what they have explained. When it is very the far away side, the amount of length it is going to cover is very small, because at any point of time between two positions, the area covered is one and the same. That is how the satellite technology will be used. When it is farthest point, the satellite moves very fast. When it comes closer to the Earth, the satellite moves very slow. So when it is slow, it is possible to capture more, let us say, images and more cover. It can cover more area of the Earth while doing. So that is how it can cover. The fundamental satellites will be working based on that one. Of course, these are all the Kepler's laws, which says the telescope is another beautiful invention with which we can see the objects, we can see the celestial objects, and still what you call educate our students what is happening, the different constellations and different formations, and how actually the movement of stars would be, how they are linked to the seasons, what is the position of Earth when it is taking, what is equinox, what is Capricorn, what is tropic Cancer, how actually this movement will affect the position of the what you call different celestial bodies with respect to your position, how the eclipses have been formed. All these things were enabled with the invent of the telescope, a beautiful instrument, which even today, which is the very, very important instrument or equipment for observing the sky. And you have to take the students to beautiful institutes like IIRS in Nainital or Mount Abu or Udaipur, where the celestial bodies are being tracked and being analyzed and being researched for their movement and for their influence on the earth. So when it comes to the exploration of space, why we should explore the space? This is the question. Everybody in space is considered as a very what you call costly domain, where the applications can be put into use. Why we should explore? Why a rocket may cost somewhere around, depends on the size of the rocket, 200 crores to 400 crores. Similar satellite may cost again 200 to 300 or 400 crores. When we are spending, and many people ask the question why we can give it to the poor, so that poor people can see, giving it to the poor, only you are feeding 1,000 stomachs. But if you develop a technology and if you generate a business out of that one, lakhs and lakhs of people are becoming what you call self, let's say, driven and self-entrepreneur, and they are earning on their own for lives, and their generations will get benefited. That is the investment that we are doing into this space, or to the matter in any infrastructure to build the capacities. That capacity will drive lakhs and lakhs of people for years and years. If you call some poor people and give some kind of food or some kind of subsidy out of this one, what happens? Maybe for a couple of days they will get feed, but after that, and he become habituated and lethargic. So these investment on these technologies are for building a advanced society. That advanced society will bring lots of employment to the people, lot of opportunities to the people. That opportunities will generate revenue for the people to live for generations. So, and that is the applications when you take agriculture, when you take forests, when you take environment, when you take oceans. Now, so many people used to get caught in these cyclones. When we know the cyclone prediction, we will evacuate the people, and lots of lives are being saved. And disastrous management, fisheries. Let us say now our oceans that will find out where the potential fishing zones are, will indicate to the fishermen. They will go and reach out to that place and get a good catch. Otherwise, they have to struggle for 5 days to get their boat filled. With this advanced technology, within 10% of the time, they're able to get the catch and come back, and they earn revenue and with less efforts. Forests. Forest conservation is very important. Forests are important. Agriculture is nothing to say. End-to-end smart agriculture, the satellites are being used. Urban development. Today, how the traffic is managed, how the roads are planned, the town planning, where the water supply should be, where the sewage supply should be, how actually the water tanks to be constructed, how that sewage pumps have to be. These are all urban and rural planning. The satellites are playing a very big role in planning all these things. See, these are all the areas. It is only the technology will create 100 times the revenue. It is only 1 rupee if you spend, the revenue that is generated out of this 1 rupee could be 100 rupees. That's how the satellite technology works. Of course, the communication satellites, what they play a role, it is phenomenal. When you call it as mobile, or you call it as ATM applications, telemedicine and tele education, these are all the areas where the communication satellites play a big role. You may not be knowing what is happening when you go to ATM, a standalone machine, and draws your money. Maybe your account may be in Kashmir or Kanyakumari. You will still get within no time the exact amount to a to a very authenticated sources how the satellite technology is used for that. So when the space race started, it's all started with very political advantages and some kind of competition, I should say. But after all, after that, when entire space race started, the ISRO entered into the space program with a very modest uh, what you call entry with the Dr. Vikram Sarabhai having a very good vision how actually the space technology can be put into use for the social upliftment. So with that notation, when we have started in the year around 1970, even the space program started way back 1963 with the foreign collaboration, after getting good amount of handover on the systems, now we move to our own self-reliance based, self-reliant space systems for manufacturing the rockets, for producing, fabricating, and assembling and launching the rockets from our own land, and building the satellites and satellite applications in our own soil. So that has resulted in so many achievements. We call it as Chandrayaan 1, Chandrayaan 2, Mars mission. Our brains are extremely good brains. And given chance and given an opportunity, our guys will do wonders. That is the example of Mars. When Mars, many of the advanced space-faring countries, where the people have been put on the moon in 60s, so such kind of advanced countries also never achieved reaching to the Mars in first attempt. The Indians have reached. Similarly, Chandrayaan 1, which has found out water molecules on the moon, it has the credit goes to India. Again, Chandrayaan 2 and 3 combined mission, which enabled Indians to send a probe and to send a satellite onto the nearer to the South Pole. It has been achieved. It is a world's remarkable achievement which other nations have not done. So basically, the Indian brains are very, very innovative, very, very practical, and they can transfer or they will convert the technology, the bookish technology into the applications and technology and bookish science into the technology and applications and succeed in the first attempt itself. This is the habit of Indians, and you are not different from the scientists. The scientific temperament, such kind of success stories where you want. But I see obviously the Indians have got a tendency, unless otherwise you provoke them or you escalate them or you motivate them, their true power will not come out. Especially in the rural children, when they have abundant knowledge in the innovation, they have to be put in a right track so that their thinking process will enhance and their ability. It is like Hanuman, you have to tell your strengths of an individual to them. You are great, you have to do such kind of innovations. The other people have done it and you are not different from them. These are all the success stories to be told to the youth for motivation. So now the India is completing, having acclaimed the capability of reaching moon. Now Chandrayaan missions are being continued with the seeking the permission of the government. Now we are also thinking how actually we can live on the moon, how actually we can build the structures, build the different kinds of what you call the livable elements on the moon. That is what the research is now going on. And I hope by the time the students of maybe 15 years, 14 years, 15 years, they reach another 10 to 15 years, we will definitely put International Space Station, that Antariksha Bharati Antariksha Station, we call it as, because popularly ISS is known to the people. We also going to construct one Bharati Antariksha Station in this space. Our scientists are going to go there and do research and bring laurels to the Indian society. So what we do, because for this one, these are all visions and these are all dreams, what we do. So we have a very good, let us say, handle on the satellite front. I'll just show in another couple of minutes. These are all some of the fundamentals, probably, I think, The teachers can teach to the students what are all polar orbits, what are all geosynchronous orbit, what is the difference between geostationary and geosynchronous, what is the importance of geostationary. When a satellite is positioned in this orbit, it always looks at one place because the rotation around the Earth is exactly synchronized with the rotation of the Earth. So most of the communication satellites and meteorological satellites will be positioned in this, so that always the satellite looks at the looks at India and keeps giving the real-time information. That is the reason. So these are all fundamentals can be talked. What half non-bent orbits, how actually this is what exactly I was telling you, maneuvering the orbits to reach the apogee to exactly near to the moon's let us say domain. So when you just to give a small push here, it raises enormous amount of the raising of the perigee will happen, and ultimately it will go near to the orbit of the moon. These are all fundamental principles we have exploited with the least cost. How still we'll achieve what we want to achieve. So these are all fundamentals of science which we have made applicable. And Chandrayaan 2 also the same thing. Mars orbiter. This is a fantastic mission management where the ISRO has done, exactly because Mars is moving around the sun, Earth is also moving around the sun. When exactly you have to kick that satellite out so that after several months it exactly go to the Mars orbit. This is a beautiful mission analysis our scientists have done and exactly predicted the time when at what time they should kick, so that it will after 6 or 7 months it will go into the Mars orbit. So you just see it has gone out beyond the moon, beyond the sun, because Earth could not track the satellite. In spite of that one, when it appears first time after taking a round around the sun, in the first moment itself, from tens of crores of kilometers away, the satellite was tracked by the Indian ground systems, ISRO ground systems, and we could establish the connectivity with the satellite so that the orbit maneuvers around the Mars had happened. This is a mission, beautiful mission, which has lived almost for a day, for less than a decade, I should say, and given lots of data about the Mars, and research community has benefited out of it. And ISRO is also now planning how actually we can have some more Mars missions. It is on the drawing board. Definitely, I hope that we will succeed with the support of with the blessings of the government in this research. And some people will ask about the debris. When lots of launch vehicles and satellites, not only by India, America is launching thousands of satellites. China is launching, Russia is launching, ESA is launching. What do they? What will happen when they're all there crowded in the sky? And will they come? Will they cause harm to the Earth, or will they cause harm to the other satellites? Yes, this is a concern today, and the debris mechanism, debris policies are in place. And in the recent past, you would have seen in the news, ISRO has brought back the satellites into the atmosphere. When it comes to the atmosphere, it is something like that. When it is in the 900 kilometers, you will deboost and you will lower the orbit of the satellite, so that our satellite will slowly drift to the atmosphere. In the atmosphere, because of the velocity that it is picking up and coming down on its own, it will get burnt. So only thing is your effort should be to bring back that back into the atmosphere. So this we have been successfully doing. This is a responsibility of any space agency to keep some extra fuel in the satellite. So at the end of the life, at appropriate time after the assessment, you will fire the deboost motors and bring down the satellites to the atmosphere, so that atmosphere on its own it will get smashed, or it will get vanished. So this is the mechanism now many of the space industry, space agencies are taking, but where already it is a dead element, it doesn't have provision to come down to the atmosphere. So such kind of elements, let's say some stages are there, spent stages are there, some structures are there which are moving around. So they do cause harm to the other satellites, very rarely, not very often it happens, but there is a mechanism that we can track the live elements and we can maneuver them and protect them in a safe maneuvers. Still, we can have a safe satellite in the orbit. But as every day or every week, so many satellites are going to that, but it's a major concern for the future how actually we will clean the debris. This is one area where future students can hop on, can spend some time, and huge business is there in this area. So launch site. In the launch site, we have a Satish Dhawan Space Center, which is 90 kilometers north of Chennai, which is a beautiful space airport, spaceport, which is the second best spaceport, I should say. One is Kuru. How this second best will be decided is based on the distance from equator, because whatever the satellite that you send to the geospatial LEO satellites and polar satellites can fly any place, but these bigger satellites are communication satellites. How close you are to the equator that decides your position and your placement on the map, how best you are in the world scenario. Okay, how actually the rocket moves, why only east coasts are selected, because of the advantage of earth rotation. We do fly our satellites towards east. So in the east, when the spent stages fall, it should not harm the habitants. That is why we choose to fly the rockets on a non what you call habitant areas, mostly seas. So that is the reason we choose the east coast. Whichever the best spaceport that you see, they're all in the east coast where sea is supported on the east. So these are all different trajectories, and there are different types of launches. One is vertical launch, horizontal launch, vertical takeoff, vertical landing. That's what SpaceX do with the Falcon 9. When it goes up, again they bring back the stages so that the cost of launch, it is only structure only the most costliest part in the rocket. When that structure is saved, you will definitely save on the launch cost. These are all low cost launches, I should say. Now, for bigger satellites, anyhow, it will not come. There's recovery is possible only for ISS kind of thing. When 100 kilometers orbit, when you go, it is possible to recover. Let's say if you have to push the satellites to 900 kilometers or 300,000 kilometers, such kind of reusability will not happen. But anyhow, now since India is also engaged with the Antariksha station, we should also look for such kind of stages where we can reach the cargo at a comfortable and affordable margins, and we can continue the program at lower cost. So these are all the number of launch vehicles what we have. We started with SLV3, ASLV, PSLV, Workhorse, GSLV, and how this is the technology which we have nurtured through Russian stages on the upper stage. Now GSLV Mark 3 is the Bahubali which is being used. Now you can go through this literature very leisurely, and you can disseminate this information to the students. Before I am closing, I just want to touch upon the Gaganyaan program, which is another prestigious program of ISRO, which has been blessed by Honorable Prime Minister during his independence speech a couple of years back. We want to put our Indians into the space and safely return them back. This is only a demonstration, let us say, project, which will have a continuity program. How actually this kind of manned flights can be used for Bharatiya Antariksha Station or man on moon mission, such kind of things. We have to develop the capabilities of qualifying the systems, taking taking the people safely. In case of any eventuality, they'll abort. The crew has to be saved, and it contains robotic machines so that human life need not be put into stake. We have such kind of programs are there. Probably the students, the days to come, they will enjoy the successes. These programs are planned in 1 or 2 years from now. Keep watching the successes and of the ISRO for you to be proud. And this is the reusable technology which winged bodies. See, usually in the Gaganyaan program, the crew module will be dropped into the sea. But to be more, let us say, comfortable, a winged body is always a best thing for reaching to the earth in a very more comfortable position without much hazards. Otherwise, what happens? You have to find the crew module where it is drop. You have to rescue them, and it takes some time for the crew to come back to the earth to go into the safe zone. So this winged body is a very good concept, which ISRO is also done successfully the demonstrations. We have to scale it up for taking a couple of people into the space and return them back. And air breathing technologies, these are all new technologies. I'll just rush through some photographs. Some of the solid propellant and segments, how actually they will do, how gigantic the processes are. Many people would have not experienced such kind of processes in their life. Is for the benefit of the people. See, these are all the solid motors. One segment will be made. All 3 or 4 segments will be joined together on a launch pad. These are all big buildings, big infrastructure created inside the secured zone, so that these are all operations will happen to produce the motors. And whatever the gigantic facility that you ever seen would be smaller than these facilities in a real sense. These are all test firing of motors. Huge equipment will be there. This ISRO has spread across the country at 7 to 8 major locations and another 10 minor locations. And the lots of the satellite centers are there in Bangalore and Ahmedabad. The rocket centers are there at VSSC Trivandrum, LPSC Bangalore, Valaimala, then near near Mahendragiri. Shar Sriharkota, Satish Dhawan Center, Sriharkota is the spaceport. We have application centers at Hyderabad. So many centers serve the community. That's how the space domain is placed in India. These are all couple of photographs for the benefit of the students. And ultimately, this kind of gigantic rockets, which is 44 meters height and 630-ton weight, without any support, it will fly between 2 stations. One is assembly building, another one is launch pad, and majestically leaves the spaceport for its adobe into the space. So these are all the launch pads, what you see. This second launch pad and first launch pad. First launch pad looks like that. Second launch pad looks like this. There are different facilities which are connected to meteorology, connected to instrumentation. This is the launch center where all senior executives will sit and give the final command for the takeoff. And Chairman ISRO and center directors will sit here and do this one. So thank you. Thanks a lot for the